Hi, this is Mr. Max. I am doing a revision question or practice questions on differentiation. Um, I am doing about three of them that I want you to sort of pause the video and see if you can do it on your own. But let's just go directly on to the question. Okay, there is, however, a little sentence that I have included here towards the end. If my videos are proving to be helpful to you, then maybe you can also think of making some sort of donation. Um, because if nobody says, listen, Mr. Max, help me with this, and there's nothing coming, then one thing that everything is fine, then, you know, help us build this channel so that it can be out there for many, many more years to come. Okay, right. We're going to look at a few just that are affected. I'm now going so quick on it. I have a question here. I'm going to do some differentiation questions on trig functions, okay, where you have to use the chain rule. And then I have another question here where you're also going to have a natural log functions, how to find the derivative of natural log functions. Quite complex, but we are going to do quite a lot of cleanup of algebra, so you can see how that one is done. And then there's a question here that deals with finding the angle between a tangent and a line ultimately. But first of all, the first part is you have a diagram. It shows a line. As you can see, the line is there, 2y equals x plus 5. That's a straight line. And a curve, the curve is there, x squared minus 4x plus 7. Now, when they intersect, the issue is at those various points, the two functions are exactly equal. So you will be solving them simultaneously in order for you to find the unknown values. Okay, and this is ordinary level stuff. So we expect you to be able to solve simultaneous equations where one is quadratic and one is linear. Now, this I can write it as y equals to x upon 5 all over 2. And I'm going to substitute this in here for y. It's much better than trying to make x the subject of the formula, but you can go ahead and do that if you want to. So eventually I'm going to say that x over x plus 5 all over 2, I'm going to let it equal to x squared minus 4x plus 7. So there's just a little bit of algebra that we have to do over here. So bottom line, just multiply throughout by 2. That will do 2 multiplied by x squared minus 4x plus 7. So this gives us 2x squared minus 8x plus 14. So you're going to move that x plus 5 over, because quadratic equations, they are supposed to equal to 0. So you have got 0 is equal to, you have 2x squared, you have minus 8x. Of course, you can go ahead and say minus another 8, another x rather. Okay, then you have plus 14 here, and then you bring the other constant, you have minus 5. Eventually, you will have 2x squares minus 9x plus 9 is equal to 0. So this is a quadratic equation that you can solve. Of course, the two numbers you should think of is negative 6 and negative 3. If you multiply them together, they will give you that 18 coming from 2 times 9. So I will definitely factorize here, but there are much sort of easier ways to solve these type of equations. Okay, you don't have to do all this factorization stuff, but I'm just trying to let people hang in there and see how far we get. So basically this over here is that. All right, so let's continue and let's take it from where we are. So we have got 2x outside and have x minus 3. So I'm now factorizing that. I have a minus 3 here. So I'm going to have x minus 3. If you do that by grouping, you have got 2x minus 3 is equal to 0. But of course, let's just do it step by step. This is ordinary level. from here as an AS level candidate, I do expect that you need to know that you can calculate these answers very easily, okay, even by means of inspection. So one value of x is equal to, so x minus 3 equals to 0. So one value of x will be 3 halves. That's moving the 3, divide by 2. Or the other value of x is equal to 3. Now, as it is, these are the solutions. X equals to 3, and the other one is 1.5, right? So that's 1.5 and 3. So at this coordinate B here, I would say, okay, here, I'll say my value of x, okay? So here, value of x is 3, and here it's going to be 3 over 2. So those are the values that we are looking for. Now, they just want the x coordinates of A and the x coordinate of B. They don't want the y coordinates. So you can actually go ahead and say, therefore, x coordinate of A is, and then the x coordinate of B is, let's just go back, the x coordinate of A, if I go to my diagram, was 3 over 2, okay, 3 over 2. So we can just go and say 3 over 2, and the other one was 3. So essentially, that's it. There's just revision work that you have to do. Right. Now, there's a second part to the question. Now they are saying the equation of the tangent of the curve. Find, the instruction still says find the equation of the tangent to the curve at B. Now, let me just write down what my B x value was 3, if you remember. Now, I like to do this. It's not necessary sometimes, but because you are trying to find the equation of a tangent, in order to find the equation of a tangent, this is the formula. Y minus y sub 1 is equal to m. Then you have x minus x sub 1. So here you have a problem. You have an x point, but you do not have a y point. In order for you to find that y point, you substitute this x into the original function. You can substitute it into this one here, or you can substitute into that one there on the curve. The reason why I'm doing that, because at P here, the curve and the straight line are exactly equal. So it doesn't matter where I substitute my 3, I'll eventually get the same y value. So I'll use this one. So I have 2y, because I'm looking for y. So if it's 2y is equal to that x value is 3 plus 5. So this gives me 2y is equal to 8. This gives me y is equal to 4. Now I have my complete point. So now that I have my complete point, I will be able to fill in this value here and that value here. The only thing that I'm now left to do is to find the gradient m. And to find the gradient, we need to find the derivative of that. But here's the thing. Is it entirely necessary for you to do that? Because if you, and I will definitely perhaps show where I'm going with that. Okay, because we say find the equation of the tangent at B. The equation of a tangent is going to be a line that comes like so, right? That equation that is also touching, so its gradient is not the same as the gradient of this line. Please don't confuse the two. So in order for us to find it, this is what we need to do. But in order for us to find that gradient, we need to find the derivative of this. Once we have the gradient function, then we'll substitute the value of x into our gradient function in order to get the numerical value of m for the gradient there. So this is where you simply go ahead and differentiate. So this is not a very difficult polynomial to function to differentiate. So you say dy by dx is equal to, use the sum and differences. So if you have the derivative, if you take the derivatives of sums and differences, it is the sum and differences of their derivatives. So basically you take the derivative of each one. The derivative of x squared is 2x, then the derivative of 4x is just 4. So this is the derivative function. Now, what do we know? We know that dy dx, okay, when x is equal to 3 is going to be 2. So we are going to find what is our m. This is basically what we're doing here, okay, when x is equal to 3. That is going to be 2. So my gradient is 2. So I have my gradient now. So I know my gradient is 2. The gradient of this dotted line here, the gradient of that dotted line, that gradient is equal to 2. Right, so point is 3, 4. So now we can find the equation of the tangent. So the question really wants you to find the equation of the tangent. Okay, find the equation of the tangent, that dotted line. So you're going to say, okay, wait a minute. It's y minus y sub 1 equals to m x minus x sub 1. We said we have a point. Um, the point there was 3, 4, point B. So we had a point. Point B was 3, 4. Okay, we had the gradient. The gradient was 2. We just calculated it. Okay, this here is x1. That is y1. So y minus 4 equals to the gradient. Then you have x minus 3. You can just go ahead and clean this up. That is going to be 2x minus 6, obviously plus 4 if you move that 4 over. At the end of the day, your tangent is y equals to 2x minus 2. Okay, and that is the equation of the tangent. Okay, that is what that particular question demanded from you. Now, they now are saying find the acute angle in degrees, correct one decimal place between the tangent, that tangent line that we have actually calculated. So let me just bring in, and I'll try to use the software again. So let's suppose the tangent line is something like so. Okay, it's just more or less. What we are looking for the angle between the tangent and this line. So it is this particular angle that we're looking for. We can call this angle theta. Okay. Now, I probably have to bring in a little story here so we can talk about angle of inclination. So the angle of inclination, think of your eye level whenever you look at something. Your eye level you have to be something that this is what I'm going to consider. Of course, I'm going to come down with it a bit. So I'm going to take something that is parallel, like so. Okay, so here I'm saying the angle of inclination is an angle, is a specific angle a straight line makes, like this right one, with a positive x-axis. Now, what we are now saying, what we are looking for the angle of inclination is this particular angle over here. This angle over here, which is going to be the same as this angle over there. But we're not looking for that whole angle. So what we need to do is we have to calculate that angle over there. Then we have to take the other angle, the smaller one, perhaps this one over here. I don't know if this yellow will be clear. So what we need to do is you take that big angle, you subtract this little angle here, and that's going to give you that theta. So that's basically how we are going to find that acute angle there. Okay, so again, if I have to use software just to explain the concept to you, all right, so I'm using GeoGebra, so let's just punch in GeoGebra, or you can use Desmos if you are familiar with it. There's nothing wrong. Just to show you on the software what we mean by that. Okay, so our function, our graph was y equals to, if you can go back and remember, it was x squared minus 4x plus 7. So it was x squared minus, no, it's minus 4x plus 7. So that's how our curve was. Okay, just take away this label. So that's our curve. Then we had another line. We had another line here. The line was 2y is equal to x plus 5. That's how that line was. Okay. Then perhaps I will just write this line in, just bring it in blue or something like that. Just change its color. Then we had the equation of the tangent. If you can still remember the equation of the tangent, that we calculated was 2x minus 2. Y equals to 2x minus 2. So that's y equals to 2x minus 2. There we go. So maybe we can also change the color of this one so that we don't get confused with the same coloring patterns. Good. Now the red one is the tangent line, okay, and the other one is the equation that we have from before. Okay, so I'm just going to zoom in a bit so that you can see what I mean. So what I'm talking about here is the angle between, this is the angle that we are looking for. Now, in order for you to calculate this angle, I'm going to bring in 3 points and then you will see how I find that angle, okay, using the software. So I'm going to take that, I'm going to take this point here, and I'm going to take that point there. All right, I need those points for you to see what that angle will be equal to. So that is the angle we are looking for. If I go back to my diagram, no, my diagram is messy. It's that one where I put that theta there in red. That's the angle that I'm talking about, okay? Now, with the software, you can do that. So we say, okay, let's see. We find the angle CBA. Can you see that angle is 36.87? Okay, that is the angle that we are referring to. That, because the question is also saying, it's also talking about what? An acute angle. That's what the question is. So we're looking for 36.87, but you don't have, what is it? You don't have, software for you to do that. I just want to bring in another point, which is a line that you can understand what I mean. If I was to draw a line like so, okay, the definition here says the angle of inclination, obviously from a straight line, so a line parallel to the x-axis, and it goes counterclockwise in that direction. So the angle we are looking for is this whole angle that I'm going to take, that big angle over there. I'm going to take that big angle over there. Okay, can you see it goes up to the red? So I'm going to use that, and then I'm going to look at the small angle over here. Now, what is important is, and I want to bring this in. If you take the red one here, if we consider that triangle, I want you to have a look at that triangle nicely. Okay. Anyway, if you look at that triangle, now if you were to calculate that angle over there, can you see that? Which ratio do you think we'll be using to calculate this whole angle over there? You have got a opposite side divided by a adjacent side. Okay, the opposite side, if you look at that, that's 1, 2, 3, 4 divided by 2. If you take 4 divided by 2, do you realize the gradient is equal to 2? So the gradient of this line is 2. So we will equate that gradient of 2 to the tangent ratio, because the tangent is the opposite divided by the adjacent side. So that's what you are expected to do. So in order for you to calculate, you will be saying, okay, I'm going to take, now let's choose a better color. This is horrible. Okay, let's even choose, I don't know, right. you're going to say the tangent of a certain angle, I will say angle 1, is equal to the gradient of 2. So what that means, it's the way, all the way that I have the one that blew up to there, because that gradient of that red line is 2. Now, what is the gradient of this other line here? This line, 2y plus, no, it's 2y is equal to 2y is equal to x plus 5. What will the gradient of this line be? Because I want to find also this angle from here using that gradient concept. Right, that gradient is going to be y equals to x divided by 2 plus 5 divided by 2. So the gradient of this black line is, the gradient of that one is nothing but a half. You can see that, 1 over 2. So let's take that one too, and let's say that is our second one. So we're going to say the tangent of the other angle is a half. Now we use our calculator and we find what those angles are, and then we should be able to subtract them in order for us to find the acute angle between them. So when you do the, obviously here, you are going to take the inverse tangent of 2. Here, you are going to, this is the second one, the same thing, of a half. And we are going to compare our results. Okay. So to see what is it that we are getting. Okay, just separate them. So let's bring our calculator back. So we have got the inverse tangent. Make sure your calculator is in degrees mode of 2. Well, that gives you 63.43. So that's like 63.43 and so on degrees. Okay, let's bring back our calculator. Then the other one was a half. This is also one on this side. That's one on this side. So a half is 0.5. That's 26.56. 26.56 and so on and so on. Now, the acute angle between them, okay, because the question is asking, calculate or find the acute angle between the two lines, okay? The way you find that acute angle, you simply say the acute angle, or the angle of inclination that is being formed, you take 63.43 minus 26.56. I could have actually played around with my rounding a bit more. Okay, so let's just use the calculator. So what I'm going to do on my calculator, I'm just going to put the correct values. Okay, so I'm just going to say inverse tangent of 2 minus the inverse tangent of 1 over 2, because I don't want to deal with 36.869. 36.869. So it is 36.869 and so on degrees. Now they continue telling me that I must calculate or give this answer correct to 1 decimal place. And since that is the case, then this is just going to be what? 36.9 degrees to 1 decimal place. Now, surely this is what we have calculated. Can you see that? That's about 36.9. Can you see that? That angle there, over there, that alpha. That is what we were talking about when we are saying find the angle of inclination. Right. Again, I said I hope it was a bit helpful that you probably try the question on your own, but it's a little bit, technical, especially if you don't have the software. But you don't need to have the software in order to approach that question. Okay.